Alright, in this video, I'm going to show you how to use the differential scanning calorimeter, or DSC. This particular model is a Perkins-Elmer DSC 7. So that's the one that we're going to be using during our lab. So I'm going to run you through how to operate this machine from start to beginning, assuming you already have the sample prepped. So that was the previous video. So I'm going to show you how to put the sample in to the DSC and where the reference is. And then I'm going to show you how to program the computer for the type of run that we need to. And then I'll show you how to wrap up as well. Okay, so the first thing that we're going to do to start the DSC is that we always want to make sure we have the gas running. And so for our setup in this lab, we are going to turn on the main valve to the nitrogen. So just turn it clockwise. If it isn't already, you should see pressure in this reading here, and we have that set at 20 psi. This is ultra high purity, or UHP nitrogen, that we're using for this experiment. So it is very dry and it doesn't have any impurities. So we open the main valve, and then we're also going to open this valve over here on the side. That might be a little harder to see. Let me move it. So this valve right here, we're also going to open this, and this allows gas to flow through this manifold into the DSC furnaces over here. So that's going to be our first step, is to start the gas flowing. And again, ultra high purity nitrogen is what we're using in this case. Okay, so now I'm going to show you how to insert the sample into the DSC. So you'll notice that you can kind of see inside this pseudo glove box. And so I've got gloves on just so that anything I touch, the oils in my hands won't contaminate. And so the first step I want to do to insert my sample is to lift up on this, and then this lid slides over to the side. And so it might be a little hard to see, but there are two circular furnaces in this case. So one of them is where we're going to put the sample, and the other one is where we're going to have a reference material. And that's where we get the differential part of differential scanning calorimetry. So we're always comparing to a reference. So in this case, the reference is on the right side, so this one, and then our sample is going to go on the left side. So the first thing I'm going to do is I'm just going to open up one of these. There's actually a little tiny lid on each one of these furnaces. So if I use tweezers and insert them into these two holes and lift up, I'll take off that lid. And again, it might be kind of hard to see, but there is a small aluminum pan with a lid on it with nothing in it, which constitutes our reference. And then, so we're going to just leave that alone. We have the reference already set, so you won't have to adjust that. So I'm going to go ahead and put that lid back on. Sometimes using these tweezers can be difficult. Okay. And now I'm going to take the lid off of the other container, which is our sample furnace. So right now there's nothing in that furnace. And so I'm going to grab my sample that I have. So this is one that I've, if you can kind of see it here, this is one that I've already prepped. So it's that aluminum pan with a lid, and our sample is enclosed in it. For this one, it's sample 8. And so I'm going to place this lid side up in case there's any spilling. So lid side up. And then I'm going to put the furnace lid back on, this metal piece, with the tweezers. And then I'm going to slide back on this top piece and lock it into place. Alright, so that's how I put the sample into the sample chamber, and then I have the reference already in place. And so now we're all set to go. We have the gas on, we have our sample in, and I'm going to switch it over and we're going to look at the computer program in order to control the DSC. Alright, so we've got our sample in the machine, the gas is on, and we're ready to set up the program on the computer. So this is the computer screen you see here is the one controlling the DSC, and also our TGA, which is using the same software, which is called Pyrus. So I have already opened Pyrus, so you can see the Pyrus manager here. There's also another shortcut as well. So if it's not already open, then you would double click this Pyrus manager program, and this screen should pop up. The other thing we want to sort of draw attention to is up here. So up here it says DSC 7, and right now it's clicked on, so it's recessed, and there's a green light. So that means that DSC is operational and ready to go. You can also see the ready light lit up on the DSC instrument as well. So everything is ready to go. If not, you would want to click this DSC 7 to make sure that it's running. Alright, so that's all set to go. You'll also notice again the TGA, which is another instrument hooked up to the same software. So we won't deal with that in these videos. But the first thing that will pop up is this method manager. And so we're going to kind of go through this screen by screen and fill this out. So this is sample 8, so I'm going to label it with the sample ID sample 8. I can make a comment that this is from MSE585 and this is 2020. And then I could also put my name in there if I wanted to. So let me go ahead and do that. All right. You would also put the weight in here. So this sample is 11.3 milligrams. So this is just the weight of the polymer. You don't have to input the weight of the pan. And then I'm going to go up here to browse, and I'm going to put it in whatever folder I want. So for me, I'm going to put that in MSE585. We don't have a folder yet, so I'll go ahead and make a new one, which is 2020. And then all of our samples can go in there. And I'll call this one again sample 8. So that'll be my file name for that. So I've got sample 8 is the name. It saves it as a .dsd, which is a proprietary file for this Pyrus software. I've got the sample ID, operator ID, comments if I need them, and the weight. That's important as well. So next thing I'm going to go to is the initial state. And so basically this shouldn't have to be changed, but because all of them are the same. But the initial state is that it's going to go to switch the gas to nitrogen at 20 milliliters per minute. So that's a standard that we use. The initial temperature we're going to set to 30 degrees Celsius, and then the initial power is going to be 40 milliwatts. So these are all just kind of standards that we use for DSC. Next, the actual program that we run is here. And so you'll see that the first step is to hold for 5 minutes at the initial temperature of 30. So this is to sort of equalize everything and make sure everything is stabilized before moving on to heating. And our heating, which is our second step, is to heat from the base temperature of 300 to, base temperature of 330 degrees Celsius, and then it goes up to 300 degrees. So this is our final temperature. And so most of our samples are going to be run at 300, with some exceptions for some higher temperature polymers that we may have a different temperature. So if you're looking at data and there's 350 or 400 or even 500, the only difference is that we've set this temperature down here. Instead of to 300, we've set it to whatever we need to. And so that is the only thing. The rate, the temperature rate is the same. We're going to use 10 degrees per minute as our heating rate from the initial to the final. And then those are the only 2 steps. So what that means is that when this is done, the machine itself naturally cools down to room temperature. And so we kind of just do a natural cool down, which is very quick in these cases, so in a matter of minutes. And so this is a very simple program, but the main takeaways are the top temperature and the heating rate. Those are the things that you really want to make sure that you have set, and we can set those down here. And so I'm going to leave that alone because I want to only run it to 300. But again, if your sample dictates a higher temperature, then you can change it here in the program. And so if you click the last one, this just gives a summation of the program that we're going to use. So we have the program set, samples in the DSC, the gas is on, and so at this point we are ready to go. And so what I'm going to do is I'm going to click on what the screen behind it, which was the instrument view. So this is the real-time view of things. You'll note that we have temperature on the X, and then heat flow, which is in power units, so milliwatts, on the Y-axis. And it also says the sample temperature that it's at right now and the heat flow that it's at right now. And so when I'm ready to go, I'm going to come over here, and you'll see the top button says start stop, and that's all I have to do. That will run the program that I just set here in this program. So by hitting the start button, it will start this program for us. So you can see now it will list the time remaining. So this will take a little over 30 minutes, and it'll tell you the step time. So this first step again is a hold for 5 minutes. So for the next 5 minutes, it's going to hold at 30 degrees. And then after that, you'll see the program, and you'll see the heat flow as a function of temperature plotted as both the sample and the reference pans or the furnaces are heated up in the same manner using the same beginning and end temperatures and the same ramp rate. And then it's going to measure the power difference between those furnaces. So how much power does it take to heat the reference versus the sample? And so that's what you're going to see graphed here. And so I'm going to leave this running as it goes. So in the video, you'll probably see this speed up. And so you'll see the curve develop as the run is occurring. Okay, so we've finished the DSC run. You can see that from up here. There's no time remaining, and there's no step time. So this is all done. You can also note that the temperature is back at 30 degrees. So it's safe to take out the sample. And so I'll get the camera set up for that and show you how to take it out. And then we will do some analysis. All right, so we're ready to take the sample out, and the sample removal is going to be basically the reverse of what we did to put the sample in. So nothing tricky here, but we'll just go through it. Open up the top, slide it counterclockwise, and you'll recall that the sample is on the left, the reference is on the right, so we're not going to touch this the reference. We're just going to remove the sample, and so we remove the top of the furnace by putting the tweezers in the holes there, and then we're going to use the tweezers to remove the sample pan, and it might be a little tricky to get out. Sometimes it's a little tricky with these tweezers, but we want to be as gentle as possible because these are delicate instruments. Oh, almost. Alright, I got a hold of it. Oop. So again, these are sometimes tricky to keep a hold of. So we'll take this out. Ah, got caught on the rubber here. Alright, let's see if I can do it this time. Alright, so I took that out. We always kind of keep these afterwards just in case anything anomalous happened during the run. That way, if we want to measure it, so we could take the mass and see if anything is lost or gained during the run. So we tend to keep these for a little bit until analysis is done. So I can put this back in a file to keep it ready to go. But otherwise, I'm going to put the lid back on and put it on top of the furnace, and then slide this back into position and lock it, and then that is all ready to go. So after that, I'll come back over here to the gas. So when we're done for the day, when we're done with this instrument, we're going to basically do the reverse. So we're going to close this valve so that it stops nitrogen from running, and then we're going to close the main valve so that we don't constantly flow nitrogen before the next time we go. So that's the state that you'll want to leave it in when the runs are done. All right, beyond that, I'm not going to show you the shutdown procedure for the instrument itself. So if you kind of look down here, this should always be on, and the same thing with the control computer over here. These will always be on. We're going to just leave those on, so we won't show you how to do that. That's something we'll leave to instructors and lab personnel.